Hello everyone, I'm Shai Almog. It's great to be here at JCON to talk to you about debugging in production and developer observability. Because of the way the talk is structured, I can see your questions while I speak. So just write them in the chat and I'll answer everything at the end of the talk. I also have another session on Thursday about general debugging tips, which I'm very passionate about, so please check it out. But first, a few things about me. I was a consultant for over a decade. I worked at Sun, founded a couple of companies, wrote a couple of books. I wrote a lot of open source code and currently work as a developer advocate at Lightroom. My email and Twitter accounts are listed right here, so feel free to write to me. My DMs are open. I'm currently busy writing a couple of books, the first of which is getting really close to completion, and it's a book about debugging, which, again, subject I'm very passionate about. Follow me online to get notified when you can purchase it. It's very close to completion. The entire book covers a small portion from a couple of chapters. The entire talk covers a small portion from a couple of chapters that I have in the book. So it's got lots of material there beyond this. So let's get started. I love APMs. They are absolutely wonderful. And I'm old enough to remember a time where they weren't around, and I'm just so happy that we moved past that. This is absolutely amazing. Dashboards and the details that we have there, we're truly at a golden age of monitoring. When I started, we used to monitor the server by going over and giving it a kick and listening to see if the hard drive was spinning properly. Today with Kubernetes, the deployment scaled to such a level that we need tools like this to get some insight into our production. Without an APM, we're, well, not blind as a bat, but it's pretty close. A lot of the issues we run into start when we notice an anomaly in the dashboard. We see a spike in failures or something that performs a bit too slow. The APM is amazing in showing these hiccups, but this is where it stops. It can tell us that a web service performed badly or failed. It can't tell us why. It can't point at a line of code. I want to stop for a second and talk about a different line, this one. On one side, we have developers, and on the other side, we have the ops or DevOps. This is a line we had for a long time by now. It's something we drew out of necessity because when developers were given access to production, well, I don't want to be too dramatic, but when developers got access to production, it didn't end well. This was literally the situation not too long ago. Yes, we had sysadmins, but the whole process used to be a mess. That was no good. We need a better solution than this hard separation because the ops guys don't necessarily know how to solve problems made by the developers. They know how to solve ops problems. So when a container has a problem and the DevOps don't know how to fix it, well, it starts a problematic feedback loop of test, redeploy, rinse, repeat. That isn't ideal. Monitoring tools are kind of like the bat signal. They come up and we, the developers, we're Batman, Batwoman, Batperson, heroes in these cases. We step up to deal with these bugs, and we're the last line of defense against their villainy. Well, Coderbat people, you get the picture. It's no six-pack abs, that sort of thing. But a Coderbat person needs to know where the crime is because the bat signal isn't quite enough. So we need something that's more accurate and more refined than these dashboards can provide us. They can show a general picture, but they can't tell us exactly at which line of code we should look. But here's where things get hard. We start digging into logs trying to find the problem. The dashboard sent us in a general direction like a performance problem or high error rates. But now we need to jump into logs and hope that we can find something there that will somehow explain the problem we're seeing. That's like going from this jet engine to Stone Age tools. There are many log processing platforms that do an amazing jobs at processing these logs and finding the gold within them. But even then, it's a needle in a haystack. That's the good outcome, where log is already there, just waiting for us. But obviously, we can't have logging all over the place. Our billing will go through the roof and our performance will, well, it will suffer. Logs are one of the most expensive things we can do in terms of performance, in terms of costs. So adding too many of them is one of the biggest problems we can do for production. We're stuck in this loop. We add a new log, go through CI/CD, which includes the QA cycle and everything. This can take hours, days. Then reproduce the issue in production server with your fingers crossed. And it might not be something you can reproduce. You might need to wait for a customer to actually reproduce the problem for you, and that can take who knows how long. Then we try to analyze what went on. Hopefully we found the issue, because if not, it's effectively rinse, repeat the whole process. In the meantime, you still have a bug in production and developers are still wasting their time. I call this the CI/CD cycle of death, because I want to die whenever I need to go through that process. It's so painful. There has to be a better way. It's 2022 and logs are the way we solve bugs in this day and age. Don't get me wrong, I love logs, and today's logs are totally different from what we had even 10 years ago. But you need to know about your problem in advance for a log to work. The problem is, I'm not clairvoyant. When I write code, I can't tell what bugs or problems the code will have before the code is written. I'm in the same boat as you are. The bug doesn't exist yet. So I'm faced with the dilemma of whether to log something. This is a bit like the dilemma of writing comments. Does it make my code look noisy or stupid, or will I find this useful at 2 a.m. when everything isn't working and I want to rip out a few strands of hair I still have left because of this damn production problem? Only with one small important nuance. Logs cost a lot of money where comments are completely free. Debuggers are amazing. They let us set breakpoints, see call stacks, inspect variables, and more. If only we could do the same for production systems. JDWP, which is the debug protocol in Java, is remarkably insecure. Actually, no, that isn't true. That's a huge understatement. Leaving JDWP running is the equivalent of giving the house keys with a nice thank you letter for thank you for robbing me, note to the thief. It's a wide open door with bills on top. A partial workaround is to use an SSH tunnel to at least reduce the exposure of JDWP. It doesn't make it secure, but at least it's a small guard next to the door, sort of positioned there. And the least we can do. We can use a command like the one you see here to tunnel JDWP connections to the local client, so we can connect to a remote client. We do that over SSH, which is secure. We can do the exact same thing with Kubernetes using the port forward command to redirect remote JDWP connection to the local host. Port forwarding opens a secure tunnel, again, between your machine and the remote machine on a given port. In the case of Kubernetes, it works pretty much the same way as SSH, which normally you don't do to a Kubernetes container. So when I connect to localhost on the forwarded port, it seamlessly and securely connects to the remote machine. Let's demo this. Once we do that, I can just open IntelliJ IDEA and add a run configuration for remote debugging, which already exists and is pre-configured with the defaults such as port 5005. I just give the new run configuration a name, and we're ready to go with debugging the app. Notice I'm debugging on localhost, even though my pod is remote. That's because I'm port forwarding everything. I make sure the right run configuration is selected. which it is, we can now just press debug to instantly connect to the running process. Once that is done, this feels and acts like any debugger instance. Sorry, yard work during the conference is just hilarious, Maya. Once this is done, this feels and acts like any debugger instance launched from within the IDE. I can set a breakpoint and step over and get this wonderful debug GUI I'm pretty much used to. This is a great way to debug. Notice I skipped a couple of steps here, such as mapping the process I want to debug and restarting it again. With JDWP enabled, I also skipped the portion of discovering which actual server I need. There are so many problems in this process. First and foremost is the need to restart the process. We can possibly run with debugging turned on by default, but that is a huge, huge risk, as I mentioned before. Then it's breakpoints. They break. I heard a story years ago about a guy who debugged a railed system, and it literally fell into the ocean while he was stopped on a breakpoint because it didn't get the stop command. A railed system is a system that's on tracks like a train, and it started driving, and because it didn't receive the stop command, because the guy was stopped on a breakpoint, it just continued driving and fell into the ocean. I don't know if that's an urban legend, but it's plausible. All remote debugging protocols are insecure, but I can personally attest about JDWP, which I'm familiar with. It's very insecure. In fact, there are CVEs already about the products that just left it open. It isn't designed with security in mind. But it's also a stability risk. How many times did a debug process crash on you? Imagine adding a breakpoint condition that's too expensive or incorrect. It might destroy your app in production. Just loading the variables in the watch can cause unforeseen problems in some cases. This doesn't scale. We can debug one server, but a problem can occur in one server, then in another, then the next time around when you have thousands of containers running in production. This isn't a workable solution. It isn't even workable with 10 servers in production. But this is the absolute worst. Say your app has a place where it takes user credentials for login. Maybe a third-party library you use does that, or something like that. You can still place a breakpoint there and steal user login details. Worse, you can elevate the permissions of your own user account because everything is writable. Just set a value of a variable. For instance, if you have permissions for user, variable that represents that, stop in a breakpoint and just edit that field, and suddenly you have godlike permissions and you can change everything you want. This goes against privacy laws and is very damn likely. 60% of security breaches in organizations happen because of an employee. There's often a misconception of security that targets the outside world only. This just isn't true. Also, doing this in a polyglot environment is just impossible. I have multiple servers with multiple languages and platforms crossing from one to the other with a debugger. Well, in theory, you might be able to do that, but I can't even imagine physically doing that in reality. I also want to revisit this slide because I do love having APMs, and looking at their dashboard does give me that type of joy we get from seeing the result of my work plotted out in a graph. Since I guess so many people here speak German, maybe there's a word for that in German that represents it, that sort of wonderful feeling you get when a graph is so satisfactory that it represents the work that you did. Post it in the comments if it is. But here's the thing about APMs. The more you instrument, the more you have runtime overhead. The more you have runtime overhead, the more hosts you need to handle the same amount of tasks. The more hosts you have, the more problems you have because of scaling as they become more complex. So this is sort of a Schrodinger problem. By observing, we effectively change the outcome and produce a different type of outcome, potentially a worse outcome, because we have more problems related to scalability. An APM needs to observe everything. An APM doesn't know what it's looking for. Like I said before, it's a bat signal or check engine light. It's got sensors all over the place, and it needs to receive information from all of those sensors. Some sensors have almost no overhead, but some can impact the observed application noticeably. Some people use that as an excuse to avoid APMs, which I feel is throwing away the baby with the bathwater. We need APMs. We can't manage at scale without them, but we need to tune them, and observing everything isn't an option. Thankfully, pretty much every APM vendor knows that, and they all let us tune the ratio of observability to performance so we can get good results. Unfortunately, that means we get less data. Couple that with reduction of logs that we need to do for the same reason, and the bad problems we have in production just got a whole lot worse. Let's take the Batman metaphor all the way. We need a team up. We need some help on the server, especially in a clustered polyglot environment where the issue can appear on one container, move to the next, etc. So you remember this slide. We need some way to get through that line, not to move it, not to remove it. We like that. We need a way to connect with a server and debug it. Now, I'm a developer, so I try to stay away from all these management buzzwords, but the word that they use for this is shift left. It essentially means we're letting the developers and QA get back some of the access we used to have into the ops, but without demolishing the gains we had in security and stability. We love the ops people and we need them, so this is about helping them keep everything running smoothly in production without stepping on their toes or blowing up their deployment. This leads us here. What if you could connect your server to a debugger agent that would make sure you don't overload the server and don't make a mistake like setting a breakpoint or something like that? That's what developer observability does. Developer observability is complementary to the APM. It works very differently though. Before we go on, I'd like to explain what's developer observability. Observability is defined as the ability to understand how your systems work on the inside without shipping new code. The without shipping new code portion is key. But what is developer observability? With developer observability, we don't ship new code either, but we can ask questions about the code. Normal observability works by instrumenting everything and receiving the information. With developer observability, we flip that. We ask questions and then instrument based on the questions. Developer observability acts very much like a debugger, but it doesn't put our production at risk and works well with production scale. So how does that work in practice? Each tool in this field is different, but the architecture I'm showing here is identical to almost all tools. Most tools use a native IDE plugin to VS Code or JetBrains IDEs such as IntelliJ, PyCharm, WebStorm, etc. Some tools also use command line tools. Some other tools sometimes have a web interface instead of an IDE plugin or CLI only. This varies a bit, but the idea of having a client is universal. The client lets us interact with the management server. This hides the actual production environment. Developers don't get access to the production area, which is still the purview of DevOps. The management server sends everything to the agent, which is installed on your production or staging servers. This is pretty standard for all developer observability tools. Some tools only have the management server in the cloud, Some tools only have it on premise. Some tools offer you the option between both of them, but the existence of a management server is identical. Notice that this works through polling. This is true for almost all, at least all tools I'm familiar with. The management server doesn't know about production, but the agent knows about the management server. This means no new pods, no new ports need opening in production. Security exposure remains the same as it was before because the agent connects to the management server and not the other way around. So everything you have in production remains completely sealed behind firewalls and as secure as it can be. The agent is just a small runtime you add to your production or staging server. It's very low overhead and it implements the debugging logic. Finally, everything is piped through the server back to your IDE directly or the appropriate interface, depending on your tool. So as a developer, you can keep working in the IDE without leaving your comfort zone. Physically, you still can't access production and have no direct access to those servers. So it's very low overhead is one of the things that's implied from there. And that should raise the vendor alert right here. I heard that line before, right, from a vendor. APMs have been around forever and have been optimized. How can a relatively new set of tools claim to have lower overhead than established and proven solutions? And by the way, this is true for all the tools in this industry. A recent vendor made a benchmark and Lightrun came up on top, but the difference is minute relatively. So all of these tools are faster than APM, than equivalent APMs. And the reason is inherent. As I said before, APMs look at everything. A developer observability tool is surgical. That means that when an APM raises an interesting issue, we can then look at a very specific thing like a line of code. When a developer observability solution isn't running, its overhead is almost nothing. It literally does nothing other than check whether we need it. It doesn't report anything, and it's practically idle. When we do need it, we need more data than the APM does, but we get it from one specific area of the code. So there's an overhead, but because it only impacts one area of the code, it's tiny. This is the obvious question. What if I look at code that gets invoked a lot? As I said, developer observability gets even more data than an APM does. This can bring down the system, and well, we could end up here. So this is where developer observability tools differ. Some tools, such as Lightrun, provide the ability to throttle expensive actions and only show you some of the information. This is a big deal in high volume requests. I'm not familiar enough with all of the tools in the market to know which ones have that type of sandbox and which ones don't. I suggest checking that because it's a very important thing, and you don't want to damage your own system by mistake, which is possible with a problematic tool. I think these things are best shown in a demo because I can talk your ears off, but showing you a quick demo can explain this faster. I'll use Java for this demo, but this applies for other languages, specifically JVM languages, Python, JavaScript, TypeScript, and more. I'll demonstrate everything with Lightrun, which you can download for free, completely free. Pretty much everything I show here can be accomplished with that free account. Notice that most of the things I will show today are applicable to other tools in the market, to one degree or another. So I do suggest checking those other tools out and forming an informed opinion unsullied by vendor bias. I'll skip the actual setup of Lightrun since it's covered in the download process and we don't have much time. Setup of tools like APMs and monitoring tools and everything like that is always a bit challenging, and I don't want to waste our time here. Let's jump right into a demo. On the left side is IntelliJ, and on the right side, I have an application that counts the prime numbers running on a remote server. In the side of the ID, we can see the currently running agents, which are the server instances. We also see the tags above them. Tags let us apply an action to a group of server processes. If we have 1,000 servers, we can assign the tag production to 500 of them, and then perform an operation on all 500 by performing it on a tag. A server can have multiple tag destinations, such as East Coast, Ubuntu 20, green, etc. Here I have only one tag and one server process. Another important aspect to notice is the fact that we don't see the actual server. As I mentioned before, this all goes through a management server, so production can be segregated behind a firewall, and I don't have direct access to the physical production server. I can add a new log by right-clicking a line and adding it. If I ask it to log the value of the variable I, and it will just print it to the application logs. This will fit in order with other logs. So if I have a log in the code, my added log will appear as if it was written in the code next to it. They will all get ingested into services like Elastic seamlessly, or you can pipe them locally to the IDE. Notice I can include complex expressions like method invocations, etc. But Lightrun enforces them all to be read-only. But the thing I want to focus on is this. The log took too much CPU, and Lightrun pauses logging for a bit. So it won't destroy the server performance. Logs are restored automatically a bit later when we're sure CPU isn't depleted. In fact, a common misconception is that logging is faster than system.out. This is only true if you log to the file system or hide the log. System.out is actually faster than logging to console. So to demonstrate this in a recent workshop, instead of adding a log, I just used system.out to print the data. The benchmark took 3 minutes. When redirecting to file system, it took 40 seconds. Lightrun log to the console took 25 seconds, shorter than even a file redirect, thanks to the suspension of logging. Logging is remarkably expensive in terms of performance, yet we print out redundant logs all the time because we might need them. With developer observability, we don't need such logs anymore, and we can save a tremendous amount of money, of CPU power, of resources, of electricity, pretty much everything. So the value proposition here is fantastic. But there's much more. Snapshots are breakpoints that don't stop. They include the stack, the variable values, and all the stuff we need. We can use conditions on snapshots, on logs, and on metrics, just like we can in regular debuggers with a conditional breakpoint. We can apply everything to a tag, which will place it in multiple servers at once. We can then inspect the resulting data like we would any breakpoint. We can click on methods and view variables. We can't step over, but our app will never get stuck. That demo was a bit too simplistic. Here's a different demo that's a bit more elaborate. In this demo, I will add a new snapshot, and in it, I have an option to define quite a lot of things. I won't even discuss the advanced version of the dialog in this session, but I will add a condition for the snapshot. This is a really trivial condition. We already have a simple security utility class that I can use to query the current user ID. So I just make use of that and compare the response to the ID of the user that's experiencing a problem. Notice I use the fully qualified name of the class. I could have just written security, and it's very possible it would have worked, but it isn't guaranteed. names can clash on the agent, and the agent side isn't aware of all the things we have in the IDE. As such, it's often a good practice to be more specific. After pressing OK, we see a special version of the snapshot icon with a question mark on it. This indicates that this action has a condition on it. Now it's just a waiting game for the user to hit that snapshot. This is the point where normally you can go make yourself a cup of coffee or even just go home and check this out the next day. That's the beauty of this sort of instrumentation. I can set this snapshot with a timeout of 1 week and just wait for the user to reproduce the problem at their convenience. It's a pretty cool way to debug, and it changes the way we think about bugs. Because when I say bugs, lots of times people think about crashes, about failures of that sort. But I'd say even 95, 98% of the bugs that we deal with on a day-to-day basis are just one user from one company saying, oh, this isn't working for me in production, and you can't reproduce it locally, or it takes you a lot of time to reproduce it locally. This lets us help and support that specific user by placing logging or snapshots specific to their problem only on their account, and then debugging directly with the user and understanding the problem that the user is actually experiencing instantly. And this is a huge game changer. In this case, we don't wait long. The snapshot gets hit by the right user despite other users coming in. The specific request is from the right user ID, as we can see if we expand this variable below. We can now review the stack information and fix a user-specific bug. Counter metric lets us count the number of times a line of code is reached. You can use conditions to count things like how many people from a specific country reached a method. If you're thinking about deprecating a production API, this is the metric you need to keep your eye on. Notice that metrics are logged by default, but can be piped to statsd and Prometheus when then visualized in Grafana. Locally, I often just grab the current time into a variable, and then after a few lines, log the number of milliseconds that passed to give me a sense of the overhead in the method. This is what a TikTok does, but at scale and with a lot more data. We select a few lines, and then we can instantly see how much time elapsed for the execution of these specific lines. Again, we can pipe everything and use conditions. This lets us verify a performance problem in production, which is amazingly valuable because some performance problems only happen with production data, and adding logging to the production area in the most performance-sensitive area isn't something you want to do always. Because these things can be conditional, just like everything else, we can do things like add a performance benchmark only for a specific user ID, only for a specific country, etc., and verify very niche performance issues that only occur in the production environment. Again, fantastic. Security and privacy are crucial with production debugging. Block lists let us block specific files and classes from receiving user actions. This way, a malicious developer can't place a log, snapshot, or metric in a sensitive area of the code and siphon off user information. You can use patterns and exceptions to block a group of files or classes. This is something that exists in Lightrun. I think some platforms other than it have this, but you need to verify that it exists because it's a very important and crucial feature that helps solve the problem with regular debuggers. Personal identifiable information reduction, also known as PII reduction, lets us remove private data from logs automatically. If you log the user object, which includes a credit card number, you might have inadvertently violated privacy laws and many regulations. PII reduction lets you avoid that by detecting such patterns and masking them in the logs. Accountability and tracking is crucial in production. That's why every action is logged into the admin log and can be tracked to a specific user account. This means that even if we misconfigure the system, we would still be able to track potentially malicious actions of a bad actor. So if we forget to add a block list for a file where user credentials are available in plain text and a user adds a log to that file, we will know exactly who that user was, even if the log was deleted and purged. Airflow lets you write workflows with Python and other languages and execute them at scale. There are many frameworks with similar concepts to one degree or another. Frameworks for processing at large scale with short-lived processes such as Spark, etc. Lots of them have different use cases and target demographics, but they have one core concept in common. They launch workers or similar lived processes that are short-lived. They perform a task and return a response. In the case of Airflow, this is commonly used for processing data at scale. A good example for this is tagging or clarifying images. Here we have multiple independent processes that can take pieces of data, process it, and then return a result. One of the nice things about these tools is that we can create chains of dependencies where results get passed from one process to another to use computing resources in the most effective way possible. But here's the problem. This thing is nearly impossible to debug. This is so bad. Companies just let major bugs live in production and accept a pretty terrible error rate. I've heard numbers that are amazing for the failure rate in production systems just because they can't find the bugs. And they have no tools to debug these things. They have logs, but with the ephemeral processes, they lose any context so quickly, it's pointless. This is a perfect use case for developer observability, and such tools can deliver a lot more. This is the basic Airflow web UI, where you can define a DAG, which stands for Directed Acyclic Graph. It's the dependent process we discussed. Here we can see a simple image classification algorithm, which we can activate via the web UI. Normally, I'm more comfortable with JetBrains IDEs, but for the purpose of demonstration, I'll switch to Visual Studio to show how things are looking there. This is the Airflow demo that classifies images. The problem with Airflow is that we don't have an agent or a server on which our code is running. An agent can come up, process, and then go away. By the time we set the snapshot into place, it will be gone. This is where tags come in. Tags let us apply an action such as a log or a snapshot to a group of agents. That means that every agent that loads with a given tag will implicitly get the action of that tag. This functionality is very useful in regular servers too, in clusters and with multiple responsibilities. By the way, notice that in VS Code, we need to add actions from the left pane. The UI is a bit different here, as VS Code doesn't expose as many extension points as JetBrains do at this point in time. Adding an action to a tag is pretty similar to adding it to an agent. Now that it's added, let's move to the agent's view and wait for an agent to come online and trigger the snapshot. By the way, notice that the UI for all of this is similar in spirit to the one in JetBrains. We now have an agent that's running, and we got a notification that the snapshot was hit. Let's go into the snapshot tab and click the snapshot. Unlike JetBrains, we need to open the snapshot manually, and it looks more like a VS Code breakpoint, which is good as it's native to the IDE. But the core idea, the UI, is of the snapshot with stack, variables, etc. That's the same as it was in JetBrains IDEs. In closing, I'd like to go over what we discussed today. Latran supports JVM languages like Java, Kotlin, Scala, etc. It supports Node for both JavaScript and TypeScript code, and Python, even complex stuff like Airflow. When we add actions, conditions run within a sandbox, so they don't take up CPU or crash the system. This all happens without networking, so something like a networking hiccup won't crash the server. Security is especially crucial with solutions like this. One of the core concepts is that the server queries information, not the other way around, as you would see with solutions such as JDWP, etc. This means operations are atomic, and the server can be hidden behind firewalls, even from the rest of the organization. Pii Reduction lets us define conditions that would obscure patterns in the logs. Block listing lets us block specific classes, methods, or files. This means you can block developers in your organization from debugging specific files. This means developers won't be able to put a snapshot or a log in a place where a password might be available to steal user credentials or stuff like that. This is hugely important in large organizations. Besides the sandbox, I'd also like to mention that Latran is very efficient, and in our current benchmarks has almost no runtime impact when it isn't used. It has very small impact even when multiple actions are in place. Finally, Latran can be used from the cloud or on-premise. It works with any deployment you might have, whether cloud-based, container-based, on-premise, microservice, serverless, etc. Thanks for bearing with me. I hope you enjoyed the presentation. Please feel free to ask any questions. Also, feel free to write to me. Please follow me on social to keep up with my upcoming books. I already signed up to write the second book after this one finished, so there's a lot more coming up. And thank you all, staff at JCON and all of you.